The violin is a beautiful instrument. You can hear its signature sound in the concert hall, in country music, and even pop music. But how does the violin work? What are the physics behind the sound the violin makes? The violin has 4 strings. When a bow is pulled across the string, waves are formed. This is one wave. It is both a peak and a trough. The wavelength of a wave is the distance from the start to the end of the wave. It's measured in meters and represented by the symbol lambda. The frequency of a wave is the measure of how many waves pass a certain point per second. This is measured in per seconds, or hertz. Frequency and wavelength are inversely proportional to one another, meaning that as wavelength decreases, the frequency will increase. Wavelength and frequency are both related to speed through the equation speed equals wavelength times frequency. In music, each note or pitch has a specific frequency. For example, the open A string on the violin has a frequency of 440 Hz. Now, in order to change that frequency, we change the wavelength. When I press my finger down on the string, I shorten the wavelength, which increases the frequency and results in a higher pitch. Now, this is the type of sound that you normally hear from the violin, but there's also an interesting phenomenon that happens on stringed instruments called harmonics. To understand those, let's talk about standing waves. When the bow excites the string, a standing wave is created between 2 endpoints. This wave kind of looks like a 2D jump rope. The first standing wave is formed by simply playing the open string. This is called the first harmonic, or the fundamental. At the end point, the wave has 2 nodes, which are places in the wave that appear to have no motion. And the wavelength is 2 times the length of the string. The next standing wave is called the second harmonic. This one has 3 nodes and a wavelength that is equal to the length of the string. In order to create this harmonic, I can force a node by gently placing my finger in the middle of the string. This forces the string to vibrate on both sides of my finger to create the second harmonic. If I were to place my finger all the way down, as is done normally, the string only vibrates on this side, creating a different type of sound. The third harmonic has 4 nodes and a wavelength that is 2/3 the length of the string. I can play the third harmonic by placing my finger on the first or second node. Either way, I force the string to vibrate at the frequency of the third harmonic. This pattern continues, creating the 4th, 5th, and 6th harmonics. That's pretty cool. So now that you know the physics behind the violin, you can truly appreciate the beautiful sound it makes.